we are just working on that we're in class together and we're working on this. What I'd like you to do is go ahead and pause this video for a second and see if you can set this up and look and see if you've got it like the one that I have. I went ahead and set it up just to save a few minutes of time on the video, but if you've paused. Okay, now let's get going. What I'm going to do is go ahead and simplify. I'm going to remind you I have my Pascal's triangle. In black are all the numbers that I have represented, and in red I have the first one, and in green I have the second one. And notice I kept a negative I because that's like plus a negative I. Okay, so anything to the 0 power goes away, so I can ignore it. Anything multiplied by 1, I can ignore it. So let's go ahead and simplify. 3 to the 5th power, yeah, I know these. Just kidding, I don't. 3 to the 5th is 243. Plus, okay, 3 to the 4th, 5 times 3 to the 4th, actually that's 81, times negative I, plus 10 times 3 to the 3rd is 27, and negative I squared just becomes I squared, and then 10 times 9, and negative I to the 3rd is going to stay negative I to the 3rd, plus 5 times 3 times I to the 4th. Now notice I dropped my negative on this I to the 4th. The reason why is any negative to a 4th power is now positive. Okay? All right, last piece, plus negative I to the 5th. Okay, so this negative goes with the I to the 5th because that's an odd power. That 5th power came inside of there. So now I'm just going to simplify. Almost. I'm still not done yet. 243 plus, oh, it's actually going to be minus because I have a negative I here. Let's see if I can get this to erase. Minus, I have no idea, 5 times 81 is 405 minus 405I. 10 times 27 is 270, but I squared is negative 1, so it's going to be another minus. Minus 270, and then negative I cubed. Boy, that one's weird. This is going to be 90 right here, and a negative I cubed. I cubed, if you remember, I1. Let's see if you can see it if I write it up here. I'm going to pull this down a little. If we do I1, start and end your day on a positive note. The negatives are in the middle. The 3rd power, 1, 2, 3, it's worth negative I. But this is the negative of negative I, which makes it positive I. If that doesn't confuse you, I can try it again. All right, so the negative of negative I, because that negative, the two negatives make a positive. This is really tricky. It's going to make it plus 90I. And then down here, I know that that's 15. I to the 4th is just 1. So that's plus 15. And I to the 5th, that's 1 left over. It's just going to be I, but it's negative. So minus I. Okay, last step. I've got to combine like terms. Every other one is a whole number and got rid of the i's altogether. So I'm at 243 minus 270 plus 15 equals negative 12 And I'll do this one in red so you can see it. Negative 405 plus 90i minus 1i negative 316i. This is the final answer. Do not pull out a negative or anything like that. We're done. Wow. That was an amazing problem. But it beats having to write down 3 minus I squared, multiplying that out in a box and then squaring that and then multiplying again by 3 minus I. I don't recommend that. Okay, so what we're going to learn today is we're going to learn how to divide with complex numbers. I have mentioned to you all before, let me show you, I need a think bubble up here and I don't have much room for one, but I have told you all before that we cannot leave, like if you take this and put it in your calculator, if you want to try it, you can, 2 over the square root of 3. This is considered improper because there's a irrational number in the denominator. So what your calculator does, if you know this or not, put it in there and see what your answer is. And you can pause it and see. But I'm just going to tell you, your calculator multiplies by this crazy big 1. Whoop. This is my 1, okay? And what happens is the 2 times the root of 3 doesn't change, but square root of 3 times square root of 3 is 3, and now it's rationalized. There is no irrational number in that denominator. And you can put it in the calculator. Just put what I did in green right here, and what you'll notice is this is the answer that your calculator gives you. Okay, with that as a side note, to divide complex numbers with a monomial in the denominator, multiply the numerator and the denominator by that monomial. Okay, so what you can do right here is multiply by 5i over 5i, just like that. And that's going to give you 10i over 25i squared. But as you know, I squared is -1, so that gives you 10i over -25. All right, but if you recognize this, this will also reduce. 5 goes into each of these. 5 goes into 10 2 times, into 25 5 times. So the final answer is 2i over -5. Now, this is my answer. Because this negative's on the bottom, I don't have a problem with that, but often the answer that's listed is not with a negative in the denominator. This negative can be on top, in the bottom, or out front. You could have it look like this, or even this. It does not matter where that negative goes to. Please realize all 3 of these answers are exactly the same. All right, so let's look at the next one. I have a 6i in the denominator. I'm just going to multiply by 6i over 6i. And yes, there's a shortcut to it. If you figure it out, good for you, but I'm not telling you. Okay? Now, I'm going to distribute backwards with this. And this goes into 6 times 2 is 12i. 6 times 3i is 18i squared. All over 6 times 6 is 36i squared. Okay, now what I have to do with all of these I squares, hey, I kind of notice I just did these opposite. This becomes -1 times 18, and this becomes -1 times 36. So this is going to give me 12i minus 18 all over -36. Okay, there's a couple of things that we have to do here. The first thing is, for this to be in standard form, you have to swap this. It has to be a plus bi, standard form. It cannot be left any other way. So first of all, we're going to change it. 18 plus 12, negative 18 plus 12i, don't lose that negative, all over negative 36. We're going to talk about this negative because usually we do not leave a negative in the denominator, especially with a complex solution like this, with it being an addition on the top. Okay, so the first thing I'm going to do is I'm going to factor out. Do you notice there's a GCF? Hope you got it. Negative 6. It leaves 3 minus, oh, I almost said 4. Let's make that a 2. 2i over, I'm going to factor a negative 6 out of this, so it makes it really easy to see our solution. Okay, since I factored out a negative 6 on top, I want to see if I can get the same thing on the bottom. And I can. So there is my final answer. Could you use V cancelization? Yes, but be careful to make sure you get rid of that negative. Final answer, 3 minus 2i over 6. All right, to divide complex numbers with a binomial in the denominator, okay, that means there's an addition or subtraction on the bottom. Multiply the numerator and denominator by the conjugate. So, okay, what's this new word conjugate in math? I've heard it in Spanish or maybe French, but why do I have one in math? The conjugate means to change the back half, and it simply takes it from being an addition statement to a subtraction statement. Be careful that you don't think it means to negate the whole thing, because if I negated all of this, it would be negative a minus bi. That's not what it did. It's a minus bi, and then a minus bi's conjugate is a plus bi. So here's an example. Notice what's in the denominator. Wow, this could be a little bigger, couldn't it? In fact, I think I'll rewrite this. 3 plus 2i over 5 minus 4i. It's just a little small. The conjugate is going to be, and this is big, we're going to multiply by a big 1 here. It's going to be 5 plus 4i. Wait a minute, why 5 plus 4i? Why not 3 minus 2i? Because it's the denominator that we need the conjugate of. Okay? This should have said the conjugate of the denominator. I don't know if I missed it somewhere. Denominator. Yeah, I got to sound it out. Okay, so this is my big 1. Okay? Do you see that it matches? I did not go by the top. I went by the bottom, and I made its conjugate. Okay? Now, multiplying the top means that I'm either going to do FOIL or a box. Tell you what I'll do. I'll do a FOIL for the top, and I'll do a box for the bottom. That way I'm hitting 50-50. You have a chance at me doing it the way that makes you happy. So foiling the top, 3 times 5 is 15. 3 times 4 is plus 12i. See what I've done? I covered this up and I multiply 3 times both pieces. Okay, and then I cover this one up and 2i times both pieces. Plus 10i plus 8i squared. We'll take that one on in a second. Hey, foiling's not too bad. All right, so then maybe I want to do a box. Maybe, oh, you know what? I can make a box happen right here. Four minus 5i, 5 minus 4i, I said it backwards, 5 plus 4i. Multiply, 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 multiply. Okay, now I want to show you what happened. I have a 20i and a negative 20i. Every single time I do this across for the denominator, this will cancel. If it doesn't cancel in the denominator, I messed up. So this is 25, and this one right here, minus 4i squared, becomes plus 4i, or plus 4, because I squared is negative 1. So it changes the sign to positive, and 4 times 1 is just 4. So this is plus 4, which is 29 over 29. Now the one thing that I haven't done yet is I have not simplified what's up here. Gotta make sure this isn't running off the page. Alright, so 8i, I squared is -1, so this becomes a -8, and it will add back to the front. So this is going back down here. So I've got -8 and 15 makes 7, 12 and 10 make plus 22i all over 29, and 29 is prime number, guys. It will not reduce. I'm finished. But see how we got that out of the denominator? All right. So now I want you to try the next 4, and I'm going to work through them quickly. I tell you what, I want to do a separate video because I want to give you a chance to do them and see how you did on these, because if you notice, number 1 looks like the ones we did at the top. So does number 3. So I'm going to do a separate video so you can go back and watch. Okay? And the other thing I did is I did something very unusual. I want you to look at this. I gave you the homework, but in with the homework is the answer down below. The reason why I did this is because I'm not there and I want you to be able to check yourself. I did include the correct answer on your actual homework page, so you know that if your answer is right, you got it right away. This is a bit unusual, I know, but you have Delta Math to do, and now you know how to do it. And their video may be helpful as well. So I'm going to stop right now, and I will come back and finish up the you try on a separate video.